Hello, in this video we'll be talking about atmosphere and how the atmosphere on Earth actually is residing there. So before that, the Earth has four systems. The system one is the whole Earth, and this whole system has been divided into four subsystems. That's the first system we call is atmosphere. That we'll be talking throughout this semester because this is a meteorology class, and we'll be talking about the interaction about the atmosphere and atmospheric variable, different types of weather phenomena. All these things we'll be talking about that. So another Earth system is called Hydrosphere and Lithosphere, Biosphere. So Hydrosphere is confined with the water, ocean. Lithosphere, the solid upper part of the earth, and Biosphere, all the living organisms. So all these four subsystems works together, and that makes our earth as a whole system. So talking about the system, we have two types of system. Number one is called closed system and open system. So closed system means that in the system or in the subsystem, the matter cannot go out and come into the system, but energy can go out and come in. In an open system, matter can go out and come in, energy can go out and come in. So we will not be talking about the system more, but one of the system on Earth is atmosphere. That is all about we are talking throughout the semester, and that is atmosphere. So what is the atmosphere? So our atmosphere is a delicate life-giving blanket of air that surrounds the fragile Earth. In one way or another, it influences everything we see, we hear. It is intimately connected to our lives. Air is with us from birth. We cannot detach ourselves from its presence. In the open air, we can travel for many thousands of kilometers in any horizontal direction in the plane, in the rocket, or you name it. But should we move a mere 8 kilometers above the surface, what would happen if we do that? We would suffocate. We move a mere 8 kilometers above the surface, we would definitely suffocate, and we may be able to survive without food for a few weeks or without water for a few days, but without our atmosphere. Can we survive? We cannot. We would not survive more than few minutes. Just as fish are confined to an environment of water, so we are confined to an ocean of air. Anywhere we go, air must go with us. So all the atmosphere that we have, if we can make it a surface pressure, it would be a ball over the Earth's surface, exactly on the screen. So we know what is air. Air is composed of different gases. We have two types of gases, permanent gases, variable gases. We'll be talking in the next video details about that. So how far the atmosphere actually extends? It is a question that we can say it is infinite. No, it's not. But mostly from the surface to 80 kilometers above, 99.9% of the all atmosphere, the gases is in there. And from the surface to 10 kilometers above, 90% of the gas are confined. So the thickness is depending on how far we are. So as the near the surface, the density and the pressure and also the thickness or the air content is much higher than as we go all the above up. But the point is the thickness on Earth are same in everywhere, like in the tropical region or subtropical region. If you go all the way to the pole, is the thickness the same? Probably not, definitely not. So why the thickness is different in different places on Earth? So we know that thickness is much higher into the tropical region in and around equator, from 0 degree equator to 23.5 degree north. That's called, the line is called Tropic of Cancer. And from the equator 0 degree to 23.5 degrees south, the line is called Tropic of Capricorn. So in this range we call 23.5 degree north to 23.5 degree south, we can tropic. In this area we call it tropical region. So most of the time this tropical region atmospheric thickness is much higher than the subtropic or even than the pole, because there are two main reasons. The first reason is that the earth is spinning. That's the rotational force. So when we talk about the rotational force, rotation makes a high speed in spinning speed over the tropic than the pole. That means in the tropic the spinning velocity is much higher than the pole. That's why the centrifugal force, that's called outbound force, is trying to escape from the earth. And other things, that gravity is called centripetal force, inbound force, trying to keep the air towards the center of the earth. So these two force, outbound force or inbound force, together work. So outbound force over the tropic for the gas, for the atmosphere, is much outward, is trying to escape, and inbound force is strong over the pole or the high latitude. So this is the reason, one single reason, that the thickness is different. Guess what? Another reason, incoming solar radiation. If you look at that, so incoming solar radiation over the equator to the Tropic of Cancer, Tropic of Capricorn, in this tropical region we have much more incoming solar radiation. That means sun is giving sunlight directly overhead in and around this area. So is this area atmosphere is getting warm, and this warm making more lighter air, and this is making expansion. So that's why the thickness over the tropical region is much higher than the pole or subtropic. So this is the two main reason that we can say the thickness into the atmosphere is different. So it is very important. There will be a question about that in your exam.